All right, welcome everybody to this AI for All webinar series. And I am Arghya Kusum Das. And today our speaker is Dr. Orion Lawlor. But before going to the start of the presentation, I would like to give you some details about this workshop series and how you can register and how you can ask everybody to register. This webinar is mainly targeted for absolute beginners, and in this bi-weekly workshop and webinar series, we will basically demystify multiple different perspective of artificial intelligence, so that you can use it creatively and confidently for multiple different academic activities or research activities and so on. And in order to get future emails for this website or to mark your participation, please scan this QR code, and please fill up this Google form and your email ID so that you can receive the email in the future with all the materials and everything. And also, we will be recording this meeting every day, and all the recordings will be available as a playlist in our website of uaf-data-ai-lab. So if you are interested to go through the presentation later with all the materials, you may want to scan this QR code. Otherwise, you can just click on this link. I will share the PowerPoint eventually with all of you. And this is basically cs.uaf.edu/data-ai-lab. And if you just click in there, it will take you to this page. If you go to courses and workshop over here, you can see our AI for All initiative. Right now, you can see only an introductory demo, but eventually everything here will be available in the form of a playlist over here. And if you would like to see the materials that the speakers are sharing, you can just click on this menu button over here, and it will automatically open this pane. And if you just click on this button, you can see the author's biography and all. And if you would like to access the materials that the author is sharing, you just need to click this material button, and you can access all the abstract of today's talk and the materials and everything that the author would like to share. So every day by the end of the day of when the workshop is done, you will get access to all the materials in this website. So with that, with no more delay, we would like to move to the talk, and I will leave the stage to Dr. Orion Lawlor. But any question from anyone? All right, so let me set the stage for Orion, and let me stop sharing. Orion, please feel free to share.
Yeah.
And I hope you all will enjoy the talk. Thank you.
All right. So make sure everything is visible. Yeah. So in the Zoom chat, I just put a link to shared notes doc. I guess I've got some other URLs there, or you can hit the Data AI Lab webpage. So what I want to talk about today was local AI models. So this being the first talk, I realized I should probably do a little bit of intro on what AI models are. This is probably my own chat here. Yeah, getting the link. Cool. So let's see. So I'm definitely going to use the wrong mouse here. We're going to talk a little bit about how large language models work. And then most of it is running AI locally, and I'm going to do some hands-on demos there. And again, because this is kind of the first talk, I kind of like to know what you've seen work well or not work well, because that's, I mean, it's a powerful technology, but it definitely has some limitations. So that's the URL if you're I've got a editable Google Doc for people to play with. So step one, how does a large language model work? Couple of steps that we're going to be able to walk through. So step one is tokenization, right? I issue a query, it breaks it up from English text or whatever language it is into a series of tokens. The tokens turn into a high dimensional vector space on there of 1,000 dimensional vectors. It's kind of surprising that seemed to work nicely. There's some attention and then classic neural network layers. That's kind of where it's thinking about the query, the token, etc. So transforms vectors. The vectors get mapped back to a distribution over tokens, and that's the most probable token, and then kind of a long tail of other options. Then there's a sampler that picks a token, and the only design in randomness is in the sampler, and I had Gemini 3 kind of proofread my slides. So I've got a little robot icon, and the robot pointed out that floating point non-commutativity in the neural networks through running neural networks in parallel, additions can happen in different order, so you can get a little bit of non-determinism happening in that step. And I think I have an example of this. So I'm running I really like these. So this is a llama file. You can see it's one executable file. We'll see how we deal with this later. And it brings us up a little user interface. Cool part about this interface, I can go and I can say show probabilities. So if I issue a query like, hey, what is the temperature today? Then, so it's this is a smallish model. Oh gosh, and it's thinking in circles. So it's color coded. So it basically says like, there's a lot of ways it could open, right? It could say like, oh, it's so like a really short version would be, I don't know the temperature or something. Some of them are pretty straightforward, right? So if I lead with okay, the next token pretty much has to be a comma, right? Maybe you could have like some other like a okay dot dot dot, right? That would be a plausible way to continue this. So there's this whole space of possible things you can get from the same query, right? And the non-determinism is because the sampler is picking one of these, and it doesn't take the highest probability one. That actually ends up making really boring, like the maximum predictability of the text. So you want to add, it's called temperature, to see what it is. I was kind of hoping it would interpret what is temperature. So I'm going to issue that exact same query again. We don't have a controlled random seed. So let's see. So we still get okay. And now it made up some temperature data. I wish it was 10C. Yeah, so the basic idea is that you're feeding it tokens, it's spitting out tokens, right? And this is the basic process. The sampler is actually really interesting. I really like the fact that if I run stuff locally, I have a lot more control over this process than I do on a cloud service. So yeah, so the way so the things you can train, or you can train the token space, the embedding from tokens to vectors. Mostly the thinking part is the important part. So the way they train this right now, which is amazing, you just start with a random network, which would just produce a bit of total garbage. And then you have it read text and existing human written text and try and predict what the next token is. And it's trying to train itself so it can predict what the next token is. And if you think about this, it needs to understand how words are spelled, but then it needs to understand how sentences go together, needs to understand how sentences form ideas. And so in theory, I think this is probably strong enough to get you everything. It actually seems to be surprisingly good. One problem with this, so the training data gives you what's called a base model. And a base model, so if you ask it a math question, it gives you a math answer. If you ask it a paranoid schizophrenic question, it gives you a paranoid schizophrenic answer. If you ask it some bizarre like religious drug reference, it'll just continue in that same stuff. So you don't want that. No company is willing to like give you access to a base model, or you can totally download them. So they can be totally goofily insane and harmful. If you ask it horrifically racist stuff, it just continues in that same vein, which is not what anybody wants. So yeah, so the post-training reinforcement learning with human feedback, RLHF, is where they're trying to make it less terrible. Sometimes that works pretty good, and sometimes the base model behavior creeps out. So always scary. Yeah, so basically all of the text that you can get the hold of, right? So like Google trains, I'm sure it trains it all on Google Books. Wikipedia is open and totally willing to go through that. I had Sci-Hub, Twitter, and forum sites, and the Gemini 3 wanted to point out that yeah, so if there's a paywall or some legal considerations, they may try to respect some debate as to whether they actually are. So how, where you get your tokens from, and I certainly see random spiders just grabbing stuff off the internet. All of my stuff, I definitely see getting 10 times more people are, or it's 10 times more bots are grabbing it than people right now. So that's, yeah. So if you just so if you're trying to write code, for example, you just read GitHub and you read Stack Overflow and you read all of the, programming stuff on any social media site you can find and keep rereading it until it starts kind of making sense. Or at least you've memorized enough of it that you can do that. Now, if I've got 1 gigabyte of training data, that's a lot. I mean, a human being would take a long time to read through it. Problem is, if I got a 10 gig neural network, it can just memorize that. So you want a way more training data than you have network, because otherwise it'll just overfit, right? It'll just remember what the training data says rather than understanding it. I mean, it's the current training data sets are literally many terabytes of text, which is a ridiculous amount of text. Because people are getting more training data and figure out how to, and you might want to weight I don't know, a scientific journal article higher than 4chan, right, in your training data, right? So some insane forum site, you might not want to embrace that stuff. So it's been kind of nutty, honestly. So this is 5 years of training data progress, and the sort of trivia questions, is this something or other? They pretty much nail, right? Like a grade school math question or something. They're suddenly starting to be able to do graduate level math. And it's a great question, precisely. So there is debate about how much answer doping is happening in the test evaluations, right? So if you've got hundreds of billions of dollars of company valuation depend on making line go up, and the incentive for people to find the answers and smuggle them into training data is pretty big. It's actually kind of hard to avoid hitting answers to existing questions when you're reading just huge amounts of training data sets. So it's a good question how much of these are actually real. So this is this graph was prepared to argue that in early 2025 we need the hardest questions from every discipline. They gave it the really messianic name of humanity's last exam. Basically, so I've looked at some of the questions, and if you've got a PhD in chemistry, you maybe have a shot at the chemistry questions, but if you have a PhD in computer science, you have no shot at the chemistry questions, right? It's asking something about a proton doing something in benzene, and you're like, cool, I'm not even clear what it's asking. So this is the progress on scores on humanity's last exam, and the previous chart had a peak at 100%, right? Because it'll just nail trivia questions correctly, which is cool, unless it misunderstands the question. And humanity's last exam it's holding out, so that's good. Although it is still sort of in the kind of trivia style, right? That it's you need to know a lot about benzene to answer that question properly. This is superhuman performance, right? And a PhD is going to get I don't know, if I took it, there's 3% of questions from CS, so I get some shot at those, and the rest of them I basically don't. So I'm going to score in the single digit percentage, and it's the initial models from 14 months ago were scoring the single digit percentage, and they've slowly started to be able to figure these things out, which is honestly super duper impressive. And so this is from great cartoon from Wait But Why. Intelligence creeps up on you, right? So you're like, oh, it's as smart as an ant. And an ant, is able to find resources and move things around. In some ways, LLMs are not as smart as an ant, right? As far as being able to perceive the natural world and understand threats and resources and stuff. But that curve, and you can debate as to the exact shape of the curve or the height of the distance between a dumb human and Einstein. Actually, I don't even know what but the deal is intelligence. like, it'll be like, oh, ant intelligence to bird intelligence, huh, okay, and bird intelligence to chimpanzee, huh, okay. But like the point where it's like able to answer trivia questions but gets confused on certain stuff, you're like, okay. And then smarter than Einstein would definitely be like a society changing thing. So I don't know, we may be there or we may be in the like limiting out phase. So my perception of this, and ChatGPT actually had some debate on some of these, but the knowledge is superhuman right now. So like every animal in every location on Earth, it knows the name of and some of the basic like Wikipedia scale attributes, which is really impressive. Like the knowledge is honestly awesome. The reasoning definitely is pretty spotty. So if it's seen reasoning like that, it just kind of pastes it in, is my perception of what's happening in there. So it can seem like, oh my gosh, it understands this. Nah, it can output that again. Uh, honestly, I feel so. We're going to run some 1 to 4 billion parameter models, and like honestly, a smart middle school student is going to beat it basically as like basic like understanding how things work. But it has this like crazy intelligence. Honestly, like the best paid models, it's like a grad student, but not a good one, right? Like I've definitely worked with so people have some people are amazingly good at reasoning, but they just don't know things. Like if you meet like a super gifted 14-year-old, they don't really know a lot about the world, but they're able to figure stuff out really ridiculously fast. These models are the other way around. They know an insane amount about the world, but they don't really understand how it fits together. I mean, they don't operate in the world. They just, a text is all they see. Yeah. So, and I haven't seen, so like Albert Einstein was amazing because like the Brownian motion showing, why atoms are bouncing against these things, right? So it was one of the things that he explained that photons emitting electrons from material and demonstrating that EM radiation is quantized, right? In addition to just relativity, right? Being able to transform multiple domains by taking stuff that, I mean, the knowledge was out there, but understanding how it fits together and what it tells you about this sort of amazing stuff. Like I haven't seen it do that kind of stuff. And it definitely goes off the rails once you've kind of exited the training data set. So that's my perception. I actually had like a bad undergrad in here, and Gemini was like, nah, right? It didn't buy that. So I don't know. Hard to say where we're at there. So this is a satiric example of human reasoning. So somebody's asking a human, "Hey, what's 4 times 4?" And you can just like, "Oh yeah, 16." And then, "Oh yeah, so what's 1, 6, 7, 8 digit number times another one?" And it's like, yeah. So the problem is, you could imagine like some deities debating whether humans are actually intelligent or whether they just memorize things or seen things we've seen before. And like, yeah, it's some debate is exactly what I mean. I wish I knew what was happening inside the human brain as we go. Does this match with your experience? Have you, how much stuff have you all done with large language models? Oh, not that much. Arco, what do you think? This is,
Yeah, I mean, it totally match what you are saying basically. I mean, honestly, whenever I am trying to do something with the large language model, the main thing that I come across with like lack of reason.
yeah,
Honestly,
yeah.
I mean, what you exactly said.
And,
It
and,
can,
and,
yeah,
and
I can feel confident that to use it as a Google search or something like that. However, am I have a doubt like how well I can use it for
yeah,
the longest. So
yeah.
yeah.
In particular, like not understanding the reasoning behind all these facts that it knows, it can mean that it has sort of a glib, superficial appearance of looking okay. And actually, I noticed like the less you know about code, the more impressive the code that it writes is, because it's like, it admits all this stuff. And if you know about code, you're like, oh, it chose to do it that way. Okay. And I mean, part of this is like, so my ability to write code, somebody asked me to write code, and I have to open the terminal and I have to type the code one token at a time. and I can't even use backspace, right? If I screw up, just gotta deal with it. Just keep typing. Like I'm not that good. Like I usually have to like block stuff out. Shoot, that's not going to work. I'm going up and down and back and forth. Yeah, and I have a bunch of scratchpad space where I can kind of store dirt. I'm thinking a bunch of stuff about the code, and that's just so. I do feel like, and there's some Jan LeCun, one of the sort of founding fathers of artificial intelligence, thinks this is just the wrong architecture, right? Spinning at one token at a time doesn't give it the kind of like, a smart human has this big, rich mental space, right? You've got a big model of the problem, understanding how the different pieces go together. When you say something, it's reflecting, little pieces of that big mental space. And with the current architecture of the large language models, that's all there is, right? Once it spits out a token, all of those intermediate, vectors are gone, and it makes new vectors, and it maybe has to refigure out a bunch of this stuff token by token, which is, so I think, right now the models are really not very space or energy efficient, and I think one big reason why is that they don't do temporary, they don't figure stuff out unless they write it down, which is called thinking. Yeah, so yeah, I don't know who else. Glenn, have you done large language model stuff?
Well, sort of used as a glorified SLS.
It would be great at that.
In the Zoom participants.
Yeah. Oh, yeah. Zoom folks. Any observations on like what actually? Yeah. I don't know, Kevin, or the thing you've certainly done a lot with. The thing has trained neural networks himself from scratch. Have you played with the large language models, and what do you think overall?
Yeah, I did a little bit. I definitely agree with what Dr. does and you say. Basically, I think large language models is just like a very big search network, really. It trains on a very large data set, but it doesn't really have a way to like find logic of using those data.
Yeah.
And it's basically just memorize, or I guess like get an average of those data and give you that average based on the prompt that you give it to it. But if you add something that is not trained on, the model doesn't have a way of finding out to get you an answer. So there's this limitation of what the model actually know based on the data that is being trained on. So I think the best model right now have a knowledge limitation to like the current years of knowledge. Like if we make new knowledge in the future, if others research papers that come out maybe next year, the current model won't know answer to those like tricky questions.
No.
So yeah, like I say, I think it just gives you an average of what it's learned and what it's seen in the data that it was trained on.
Yeah, so I'm gonna just, so this is one of the, okay, I'm gonna try a live demo here of how to run a local large language model. I don't know, I've not tried this on this machine, so I'm not totally sure it's gonna work. So I'm gonna go to the so this is a little notes page, and the place I'd like to start is a llama file, mostly because it's really easy to install. A lot of these have like a bunch of pieces, and you got to like compile them and get this to run, get that to run. So Llama file has, so it's one file. It has the weights, it has the sort of interpreter model, it has the tokenizer, it has a web user interface, all is one executable. It's an executable that runs on Windows, Mac, Linux, x86 or ARM, which doesn't even seem possible. There's some really clever binary manipulation tricks. Unfortunately, it actually kind of looks like a virus to some antivirus stuff. So that may be what stops us here. So it's a single thing. Each of these platforms has some limitations. Actually, if you got an Apple Silicon machine like the M4s or M5s, it's crazy good. My little old M2 Mac Mini can just crank out tokens surprisingly fast. So you can download them. The traditional place you download large language models is from Hugging Face is the, and I probably need to stop share. folks on Zoom, let me know if you're not seeing the right thing here. So Hugging Face is where you get the official version, just to avoid like killing UAF's network connection. I've got some local mirrors, and these are let's see, I haven't even tried Ministral. So Quen 0.6b is actually good because it's very tiny. And I think we should be able to see some of the reasoning limitations. So I'm just going to download the llama file. And because it's local, this is actually hosted right on the our little machine room right there, aurora.cs.uaf.edu. So, of course, it downloads 1 gig in like 15 seconds. So that's cool. It's now hopefully doing the virus scan. And okay. Okay, I can't open it because it's an executable. So I actually need to cancel out of that. So I'm gonna find where it downloads this thing. And then this is so on Windows, an executable has a .exe. So the tricksy part here is I'm just gonna name it .exe. And it's like, oh no, it might become unusable or it might become usable. So it now should be an executable. And I'm just going to double click it. I've not tried this, like I say, on this machine. I mean, it's a gig. So actually, that's probably a local antivirus. Oh, okay. It doesn't know where this came from. It came from me. This one's actually okay. So I'm going to tell it to run, and then now the firewall is probably going to complain about it. So here we are. So now it's loading the 1 gig of stuff. Okay. It doesn't. Okay, I was afraid that might happen. So it exited because it couldn't find a working graphics card. Actually, it looks like it thought it should be able to find a working graphics card. Okay, cool. So if you've ever worked at the command prompt, we can give it some arguments. This is harder than it should be. Okay. I'll show some other ways to do this that are less hackery. So that's cool. Let me see if I can find where we're at here. So this is the Windows command prompts, and I want to zoom in. So we can see it. So what I want to do is I'm going to run that, and I'm going to do what I'm just going to do a -- help. And I forget how to run things on Windows. Windows uses \\. That's the thing I always forget. So llama file chat server, and I think what I need is actually kind of an unusual one, which is to say --GPU. So it supports Apple GPUs, AMD GPUs, NVIDIA GPUs, and we probably have an Intel GPU. So I'm going to need to do --GPU disable. So we're going to do, and actually, how about I just do -NGL0? So if you've got a consumer graphics card that doesn't have a whole lot of RAM, you may need to limit the number of neural network layers that fit on the graphics card. So NGL is the number of GPU layers. And let's see if this works. So load it up. Okay. And you know what? This one might be small enough that this is actually just going to work. So we got a chat window, which is fun. So you can actually just ask it stuff here. What's it? Okay. Here's a great one. Let's see. Finish this sentence. They're honestly really good. Finish this sentence is like it's bread and butter. That's what it does. Let's see. The proof that a number cannot be both even and what's the most likely token to come next? Odd, right? Even matches well with odd. So let's see what it. Okay, the proof. Let me think. So the sentence is about a number being even and odd. Wait, but a number can't be both even and odd. So the proof would be that it's impossible. No, you notice I didn't say odd. It figured it out. I didn't say I want you to prove it, right? I mean, the proof that a number cannot be both even and whatever, right? So it did pick the most likely thing, which is cool, right? So it memorized that, right? Like it knows it's seen the even and odd proof a zillion times. Okay. A number can only be even if it's divisible by 2 and odd if it's not. Oh, the sentence is completed, and odd, it's impossible. So we got kind of, it was doing so good, right? And it clearly sort of superficially appeared to understand what I was asking. And I have to say, the biggest delta to me in large language models is that computers have never been able to understand what you meant. They only understand what you say. And this is the hardest thing about programming languages is that like what you said, like you left off a semicolon, it's just like, there's no semicolon. I cannot understand how these two statements relate, right? The curly brace is missing. I cannot understand. Like, figure it out, right? And neural networks are so good at figuring it out. If you ask a slight variation of a common question, it'll be like, you're clearly asking the common question. Clearly. And sometimes it can be hard to say, like, oh, if I really meant and wanted to switch these around, could you do it? And then it's like, I could, but you probably mean. Yeah. Okay, so it's impossible to be both. It's impossible is not a great proof, right? Like that's not actually what I wanted. So I'd like to be able to change some of the parameters here. So right here in the command line, and okay, yeah. So mostly all I needed to do is add -ngl0 to make the so I'm thinking I should actually just put this in our little notes doc. So let's put this in the notes doc. This thing should be, oh, okay. I apparently did not leave edit permission, so I'm going to add a suggestion in here. So okay, if things don't, okay, if you don't have a GPU, if you don't have a discrete GPU, like a NVIDIA, AMD, etc. But you have the drivers. Drivers exist. Llama file is kind of bad about Llama file might not work out of the box. So add dash ngpu 0 ngl. Oh my gosh, 0. For some reason, it's splitting up this into a bunch of separate suggestions in a really not a great way. Wow. That's kind of unusably bad. I think I'm just going to add permissions for people to modify this thing. That's usually not a great idea to just leave a doc sitting out there that people can edit, but for this afternoon, it should be fine. So I'm just going to upgrade. Everybody has edit rights. So, okay, everybody should have edit rights now. Let's see if I can remember the needed to ask. Seems like Google Docs is getting dumber here. Actually, we're not logged in here. Maybe that's part of the problem. So I'm going to go and approve these. Might have to reload the Google Doc to get these things in there. So NGL0 is the number of GPU layers to turn off the GPU support. Might make it work. The box basically open a command line and add. Yeah, okay, that's less user friendly than I was thinking, but yeah, hard to do that. So when you fire up a Llama file, it also stands up a little web server, and that's that web server we were seeing earlier. And this is my total lack of familiarity with the. I don't know why the Windows terminal is not letting me select that. That's goofy. Let's see if I can just get to that. So 127.0.0 port 8080. See if that's actually it. Okay. I'm not on a, so Linux makes a bunch of shadow domains there. Okay, so 127.0.0.1. I'm just going to put this into the doc here. So there's a web server at that URL. Okay, copy, paste, copy, paste. Okay. And this is it's the same neural network. It's actually so we're going to get the same silly results here probably. It just gives you a lot more parameters. So you can in particular, honestly, my favorite one, show probabilities. right? So this shows the alternate probabilities for each of the tokens, which is kind of neat. I really wish it had the ability, if you could click on a token and have it regenerate starting from there, it would be really neat. Explore the possible alternate conclusions of this thing. There's a bunch of stuff in here. Actually, probably should have looked up some of these. So temperature determines how much kind of entropy. And so the neural network says, like, 70% yes, 30% no, right? If temperature is 0, it goes with the yes. And you, like say, you end up getting really typically pretty bland text. The old versions used to let you set the temperature to anything. If you set the temperature to like 10,000, it's just like, it wouldn't even complete words, right? Because it's just like, finishing stuff. It seems to be seems to be bounded a lot more now. It's actually hard to get it to spit out gibberish with the parameters that they have on there. Super interesting one. So we just saw it, like, say something not crazy about a mathematical proof. Actually, let's, so how can we make this more of a mathematical type proof? It seems to have interpreted the proof as being like more of a like hand wavy. I'm not sure why I can't select this stuff, but it's an odd. Seems
Can you try with PowerShell or?
I probably, so I'd have to restart it. Maybe CMD is not the right one to use here. Yeah, so we're gonna see the different probabilities. I'm gonna ask the same question, the same. So okay, so my initial query goes right in here. So please finish the sentence. The mathematical proof added one word, right? That a number cannot be. And hopefully it cannot be both even and. So. Okay, that's not great.
Can you zoom?
Yeah, sorry. Okay. So let is this random thing? Like, okay, mathematical proof. That's weird. Actually, this is displaying the kind of brain damage I've associated with like a totally malfunctioning network, and I've seen Llama do this for sometimes. So, yeah, that's no good. Let's regen that one. So that didn't work. Let's and some of these other interfaces have a much more friendly way to do that. Okay. Yeah, number covers a lot of ground, and the sort of like, it doesn't have to be actually, I should probably say integer would like remind it that yeah, okay. So it's thinking about how to do this. Llama file has not formatted that correctly. Oh, and yeah. Actually, I kind of think we're getting something seems to be messed up here. So that's weird. And okay. So here, okay, there's a paste. Yeah. And so if I ask the same thing in the same chat window, it remembers what we're talking about, right? Like so actually this would maybe be a better way to do this. So can you flesh that out to be a full mathematical statement? Mathematical proof. That seems more coherent to me, which implies that maybe there's some setting that we got way out of the nice zone. Okay, this is what I was expecting to see. Yeah, so if a number is even, you write it as 2 times k, and if it's odd, you write it as 2 times k plus 1. It would need to do both, right? Actually, it's not necessarily the same integer k, but yeah. Okay, so now it's formatting the thing, think of the key points, yeah, define even and odd integer. Okay, that's what we're, so surprising fact, if you just say mathematical, you get a better response out of the thing. I'm also so for some reason the command line interface seems to be a lot better. I want to do a controlled experiment. So in the web UI, I can just hit reset. In the command line, I can say /clear, and hopefully it doesn't remember what I'm doing. So you can so if I do this, it shouldn't remember what we're even talking about, right? So a full mathematical proof about integers. And it's so you notice it doesn't under like even odd, like what so that is gone, right? Because I said clear. And it doesn't know that I'm asking about even or odd. So a full mathematical proof about integers, it's a lot of space there. And a smart model, I think, would ask to clarify, right? Like so there's and it's this is almost like the Wikipedia thing where it's just like let me give you the Wikipedia page on integers, cool, and you know that's a perfectly reasonable thing. Control C, you can just stop it from talking, and you can ask like, oh yeah, can you expand on the closure under addition? Is that true of positive integers? It is. Does it know that? So the idea is if I add two non-negative integers together, I should get a non-negative integer. It's not true under subtraction. It's so this is also like yeah, so observation one, this thing is not very smart, right? It actually kind of misunderstands the question, especially in whatever parameter malfunction has occurred in the web UI. It's definitely not even coherent. You shouldn't even expect it to be coherent, right? It's a tiny model is trying to predict the next token. The fact that it says anything at all is kind of a like, you know, it's a big technical achievement. Getting to spell things correctly, right? It generally seems to spell things surprisingly correctly. Yeah, so you should address the users because it kind of seems to be echoing like it kind of knows what I want to do. Yeah, so let me clear that again. And there's a controlled experiment that I ran on a couple of these models. So I said I maybe switch here. Okay, so I'm going to stop the sharing on this. I'm going to pop open this one, share this one, and okay, so somewhere I've got okay. There's one of my llama files in case this one didn't work, and I've got
So
yeah.
I have a quick question regarding this. So is this good result or bad result? Does the quality of result have any dependency on the underlying memory? I mean, amount of memory or amount type of hardware that we are using,
Okay.
or no?
Yeah, well, so if I've got a small amount of RAM,
Mm.
I can only fit a small model, and the small models are definitely dumber. Like
Okay.
on every axis, I can like they know less stuff, they can reason less effectively. They tend to get distracted about what you're even asking. And 0.6 is right about the threshold where like, it doesn't even really work anymore. And I'm kind of surprised it doesn't. I mean, that works surprisingly poorly. Yeah, so I basically broke this up into like a couple of like so variants of mathematical statements, right? So trivially easy and true, right? The proof that a positive integer cannot be both even and. I figured out it was asking about odd, and then came up with some sort of this so did some so for the tests I did, this one was great. And then as I add some complexity here, right? So a proof that a positive integer cannot be both even and a multiple of 5. Well, 10 is even and a multiple of 5. So, and of course, like several of these were like, okay, I know this statement is false. How can I prove it anyway? Right? Which is like, that's a basic reasoning failure. And the small models were pretty bad about that. And they would admit a thing that, so let me scroll down here. So, and this is easy. I was hoping to be able to do this live. So yeah, it cannot be both even and odd as plausible. It cannot be both even and a multiple of 5. It can be both even and a multiple of 5, right? The number must be divisible by 10. This is actually great. So therefore, the statement is false. But wait, the user wants me to. And it's more willing to follow the user's directions. This is one of the problems with like, reinforcement learning from human feedback. You want to follow the user's directions, but you want to have valid mathematical proofs. These are two things that, it's kind of weighing. And to a mathematician, you're like, no, I don't care what you want. That's not true. And one thing, it doesn't make it true. So like, Okay, fine. So check out its proof. This is okay. The proof that if a number is both even and a multiple of 5, it must be a multiple of 10, which is not a prime number. Therefore, there are infinitely many such numbers, proving that a positive integer cannot be both even and a multiple. What? What? No part of that makes sense, right? Like, where did prime even come from? Prime does not imply that there are infinitely many primes. It doesn't. I mean, infinitely primes doesn't prove a false statement true, and definitely doesn't prove this. There's no connection between that and this statement, right? So it's just kind of inserted some text. Yay. Which is bad. You don't want that. And the bigger models absolutely just call it out, right? So I ran like a billion to actually Llama. Maybe this is just a bug in Llama file. Maybe I shouldn't be recommending Llama file. It's so easy. It's the advantage to this. And I like the fact that there's one thing that literally like I can run that same executable the 0.6 that just chmod plus X on my Linux machine. It runs on so the same thing runs on Windows and Linux. Goofy, super cool. Yeah, and it runs on a Mac. It's like crazy. Yeah, so this one I thought was pretty dang interesting. So the proof that a positive integer is going to be both even and a multiple of 475. Well, you multiply 475 by 2, and you get a number that is both even and a multiple of 475. But like, that's not in the training data. No one asks that, right? And you can just make up a new integer and then just get a new thing. And yeah, so same deal. The tiny models are like, this is actually false. But I need to prove it. So how am I going to do that? And it comes with some specious reasoning that allows it to think that it's so that's what it is. And so Gemma 3, the 27 billion size model, it figured it out. So let me scroll down to that. So 27 billion size model requires about 40 gigabytes of GPU memory, which is a lot, right? Like your home GPUs are going to be like, I don't know, my laptop has 4 gigs, and it's like a gaming laptop. So like 4 to 8, 16 or something is like the consumer size. So this is more than the ones that you got easy access to. Yeah, so to 27B, and actually, Glenn, tell me if I mean it's not very token efficient thinking about this, right? So yeah, so I don't know what do you think about this basic proof approach? You say, okay, if it's a multiple of 2, it's 2 times p for some integer. If it's a multiple, we'll use n. It's a little scary. So it figured out that like if it was a multiple of 950, then it's going to be it's divisible by 2, and then it's divisible by that. Doesn't lead to a counter. So it's trying to basically prove the statement. It uses the usual Diophantine kind of like proof techniques, and then they don't work. And it's like, well, okay. So this is all kind of in the thinking process. And then it says like, hey, wait a sec, this would be more interesting if you said it can't be odd and a multiple of 475. Actually, that's also false.
It's kind of wandering around trying things.
Yeah. It yeah. And it doesn't always realize when the thing's worked or not, which is a little actually it seems like when it works, it actually is fairly good at saying yes. If it doesn't work, it does. And I've actually seen students do this, right? That they're like, okay, here we are at the end. It worked, or something, it worked, right? Because they're all at the end, they want to have a proof. So they're like, well, I'm tired of writing this stuff. So that's the proof. Yay. Which, yeah. So reasoning, right? At the 1 billion to 4 billion scale is pretty bad. At the 27 billion scale, I think this is not terrible, considering this is not something it's seen before. Now, the deal is it's probably seen this, it's absolutely seen a zillion cases of this proof technique, right? Want to prove something about integers, so it tries stuff, right? And it tries not crazy stuff, I feel like, right? Look at the prime factorization. Okay, I see a 2 in the prime factorization. That means it's even, right? I see a 19. Okay, there are there are legit things that it's actually trying out. That's good. That's what I want to see, and it knows, right? It's like, hey, wait a sec, that didn't work. Which is, I feel like, kind of higher level reasoning capacity there. So so Llama file. The big advantage is one file. It's really easy to do. So the why, and we kind of demonstrated some of these things. So one of them we didn't demonstrate. If I do that experiment on ChatGPT, that goes into the training data, right? They harvest the question, they harvest its answer, they try and mutate them to make them work better. There's kind of a privacy leak there, right? If you need to ask an embarrassing question about something or other, it's going to be in the database forever. Yay! That seems not awesome. Although I should say, the university signed a contract with Google. So if you go to gemini.google.com, it does not harvest your stuff. It does remember it for your future use, but that's not used for the training because we said not to do that. One thing I really like about a local machine, you can actually run controlled experiments. So there's some command line flags, and so you can say the random number seed for picking tokens is 3. And then if you have the same model with actually the GPU ones seem to be, so the same model run on the same hardware with the same seed gives you the same answer. So you can run controlled experiments, right? I can try variants of a query and not have the randomness screwing me up there. I can do 100 experiments on the same thing and not have like the cloud update happen halfway through and totally screw up my data or have me get cut off out of the free tier at experiment number 70. So control experiments are great about local AI, and I can run like a stupid model that's dumber than people will commercially sell, and kind of recognize how the reasoning scales out. Right, I can run a really dumb one and the same model actually in slightly different sizes, which is a lot nicer. I mean, we're in Alaska, the network certainly goes down. I kind of suspect we might be a couple of like accidental anchors away from being disconnected from the outside because we still have satellite uplinks or something. But a local AI doesn't need a network, and that I mean, for disaster resilience, that actually seems really nice to have, and reference to a bunch of that stuff. So the how, I mean, there's a multi-gig file of weights, and then some kind of compute. So a GPU is the graphics processing unit, like your gaming graphics card. An NPU is a neural processing unit, like built into some advanced, the most recent chips have that stuff. And then you need some kind of an interface, like some way to put tokens in, get tokens out. Depending on the interface, you might be able to put in like images, get descriptions or images in, images out. So there's all of those things are totally possible. So so we just demonstrated this Llama file, and the stuff in there. Let's see, that is not a great animation. So you download that file, you run it, and Quen is this Chinese AI research organization, and it's also the name of their model, Quen.ai. So Quen 3, and there's so like Meta has the Llama, the family models. There's a bunch of these. So yeah. Okay, so Argo's office hours are starting. FYI. So one thing you'll see in the file name, so 0.6b means there's 0.6 billion parameters, right? So the total count of the neural network and the embedding and the de-embedding are 0.6 billion, which kind of this is actually not a big model. This is in fact about as small as you can get before it kind of just fails completely. Parameters for like commercial stuff tend to be like for training, they tend to be trained in like 32-bit or 16-bit floating point, and that makes a lot of data. So to make a smaller file and to make it evaluate faster, usually gets quantized down to like 8 bits per weight. So you can kind of run the numbers, right? If there's 0.6 billion parameters and they're 1 byte a piece, you should expect this thing to be at least half a gig in size, right? 0.6 gigabytes would be my expectation. And then there's like the quantization has a scale factor. There's the tokenizer. There's usually a bunch of kind of overhead that means that it's bigger than that. So this file is like 1 gig, but it's smart enough to like talk to people, right? It's got a whole web user interface and runs on every imaginable platform. So I don't know, it is neat. And then Llama file is the name of the executable. You'll see some other stuff in there. like you'll see IT is the instruction tuning, right? So I don't think this is quite a base model, but instruct tuning is where they try and make it like actually answer your questions, respond more reasonably to stuff. Actually, knowing what it doesn't know is one of the things you do in instruct tune, right? Like somebody, you try and get it to say, I don't know what is the answer. Yeah, so it's a Llama file. There's a lot of other options. Yeah, so Llama file is the one that we ran. I really like it because it's easy, portable, a single thing. You don't have to deal with any other stuff. There is a command line and a web UI. Ollama, it doesn't have a web UI, but Ollama is actually probably the nicest one for doing locally. You can actually make the same. My understanding is it's the same like from the network side as a ChatGPT. So you can actually, if you've got something that's used to like burning money at a cloud-hosted AI, you can actually just point it to your local Ollama server somewhere. I should actually have Ollama set up on one of these, one of our local big GPU machines. I think that's probably the one that I should be using. Ollama seems to be a lot nicer. So I've got Ollama here. So what I want to do is I've got a 4 gigabyte I forget what it will tell us here. So it's a RTX 3050, right? It's not a super great card. It's a decent, it's a gaming laptop from 2 years ago. It's got 4 gigabytes of RAM, of which only 15 megs are in use, meaning most of the RAM is free. That's the RAM to show the Windows and Chrome and stuff. So I should be able to just Ollama run, and I can run a bunch of these things. So Google Gemma 3, and I think that's probably command line. So Gemma 3, actually, let me Ollama list. So you can Ollama pull some names of different models. So I've pulled like a Gemma 3. So I've got a 1B it quat. So this is the instruction tuned and quantization aware training. And quantization aware training means that it's not trained in one size of numbers, and then those are just chopped off to make the 8-bit version. That tends to there's some brain damage that happens when it does that. So quantization aware tuning is where it's actually kind of adjusted that. And 1 billion parameters is small enough. It probably doesn't even really need a GPU, but I want to demonstrate stuff that should run on basically anything. So I'm going to just run Gemma 3, 1B, it quad, and run that stuff. So run. And it's going to load it up on so there's a little progress bar that says that it's loading it up on my local graphics card. So let's actually, what's a good question that we'll be able to tell? Hey, what's the temperature? Temperature. And it doesn't know, right? It can't determine the temperature. So this is the instruction tuning, right? So a base model, you ask what the temperature is going to be like, oh man, my town, it's super sunny today, because it's trained off of chat room stuff. If you ask what's the temperature, so I'm gonna ask the same session, what's the temperature again? And it's gonna say, I still don't know that, so it's gonna say hey, you want to look this up for something? I still don't know the current temperature. If you clear it, so if it clears the session context, I can't give you the real-time temperature. Yeah. Not quite the same stuff. Actually, okay. Weather.com exists. Is time and date a thing? Is that a real? Oh, that is a real site. Oh, cool. So I've absolutely had a large language model spit out URLs that don't exist. It's actually kind of so. This is kind of a lead into my last section here. See, what's the URL for the Swift Raylib library? And it'll say oh yeah, raylib.org/Swift. That I wish, and put in some asterisks that don't exist. I don't think there even is a raylib.org. That's cool. Yeah. So it made up what sounds plausible. Yeah. Okay. Let's try that again. Okay, gave me the same thing. I've seen this give me a difference. Okay, that's what I'm expecting. Okay, this exists. So any open source project And I don't know why I'm getting asterisks after these things. So probably good. There is no Raylib. There isn't even a Raylib. Okay. Somebody grabbed Raylib as an organization without having that actually be a thing. Yeah. Right? Like you ask it a factual question, it gives you factual answer, which is factually incorrect because it doesn't know what it doesn't know. This is a small model. It's been quantized down to fit onto something, but like, dang, that hurts. Let's see if a bigger model is smarter about that. So I'm going to quit. Control C. Oh, Control D. Okay. Each of these is slightly different. So if I look at what models I have, I do have a 4B model, and the 4B model, this is kind of interesting to me. The llama file doesn't actually fit on my graphics card unless so that there's right. So I have this much GPU RAM. The model is like almost that big, and it has like a context window and a KV cache and some other tools that just blow out the RAM size. Llama seems to be optimized to default parameters actually fit on the GPU that don't otherwise. So let's try the same thing. See if it's actually more accurate or if it's just going to lie to us more convincingly. So Earl, the Swift Raylib. So it says, oh yeah, official. So can you see how much slower this is now? Right, token, 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 right? It takes a fraction of a second to spit out a token because we're the 4 billion layer. There's no such thing. Hey, how about this organization? Is that the problem? No, there's no such organization. Raylib-community. It's plausible, right? Like that seems like where you'd expect it. You'd expect to find stuff on GitHub. That's where code lives. You'd expect to see like, Raylib is a pretty big library for this stuff, which is real. Swift is a real language. Yeah, so, yeah.
Typhoon is Orion Lawlor.
Oh, that's actually great. So I'm going to start saying like, hey, what are the top 3 cities in Alaska? And of course, what I didn't say by population, economy, or I don't know, cultural stuff. It's probably more or less the same order. So, all right, yeah. So it knows that. I think 200 some thousand. That actually, yeah, sounds plausible. I should have asked it to be more brief. Second largest city. Oh, we have 300,000 people. We totally don't. That's an absolute lie. It just doesn't remember how many people we have. It also says it's the largest city. So here's where the reasoning failure, right? Like the biggest city has 298,000 people. The second biggest city has more. If you ask it about it, then it'll just get confused about exactly what exactly. That might be close. Oh, and it'll give you. It's like, hey, do you have a citation for that? And it'll be like, yes. Sources for these things. Yes, some of these are real and some of these are hallucinated. So Alaska.gov sounds plausible. City profiles, is that a real URL? No. DCED is some kind of a typo or something. That looks like a plausible URL, except that's not a server that exists. Yeah, so that's not awesome. Okay, okay. The hardest part about doing this. Can I ask a non-leading question about, hey, what educational organizations are in Fairbanks? So K-12, oh, University of Alaska Fairbanks. I've also had it tell me about the Fairbanks University, FU. I've had it tell me about another other hallucinated. Okay, hey, the dominant force. That's a better sort of tagline than naturally inspiring or whatever we got. Okay, College of Natural Science and Mathematics actually happens to exist, so that's cool. The Murray College of Management, is that what it's called? I don't think it is. And I noticed engineering is not on the list. UA Museum of the North is a thing and talked about enough that it probably shows up. APU is in Anchorage. Oh, does it have a presence in Fairbanks? I don't think it does. APU barely has a presence in Anchorage. Warner University. I don't think that exists. Oh, and it's making up all kinds of stuff. Cool. Okay. How about tell me about Dr. Orion Lawlor at the UAF Computer Science Department. Okay. Dr. Ryan Lawlor, highly respected influential player. I agree with it already. Groundbreaking research and dedicated. Okay, that's not being very specific. Sensor networks. It's thinking of I don't actually do anything with sensor networks. So low power wireless sensor networks. Internet of Things. It's cool. I don't. Yeah. Embedded systems. Not really. Data acquisition analysis. So that's cool. Arctic research. I guess I kind of do some Arctic research. All right. That doesn't exist at all. This is a complete fabrication, right? And it doesn't even know, right? The thing is, if you didn't know Orion Lawlor, would this look plausible? I mean, like, yeah, oh, sure. I mean, Arctic, stuff. That sounds good. Yeah, published several patents. I have 0 patents. I hate them actually. So NSF grants, I have gotten some NSF grants, but like these are typical things. Oh, I'm a full professor. All right. That doesn't, yeah. I actually don't really collaborate with researchers enough around. So yeah, alaska.edu/CS. That's not our URL. So that's cool. Look over his profile on the faculty page. Polar CTN, which it just made up. I don't think this is even a real thing. Nope, doesn't exist. That is a total hallucination. Yeah, true. Can you tell me his top 3 most cited publications with references? So you'd expect to see what, like Dr. Lawlor somewhere in the author list, maybe at the end because he's this respected guy, or maybe at the beginning because he's writing his own papers. That's amazing. So even really have to think about that one.
So while it is thinking around about your publications, so is there any way to reduce this hallucination?
Okay, so okay, yeah. So that's Llama. Llama's really cool. LM Studio has a GUI. I don't like GUIs, so you can download a GGF file yourself. Llama wants to download it. I mean, with Llama file, it is the thing. Yeah, llama.cpp is the library that I think all of those are actually using internally to run the stuff. So that's yeah. So you'll see some file formats. Yeah. Safe tensors is one I haven't played with very much. Yeah, so I think the big one here would be the AI pitfalls. So it's a super powerful technology, but it can be misleadingly powerful, right? In particular because it knows how to speak English really convincingly. It can kind of read between the lines, figure out what you want it to tell you, and then tell you. And I mean, the bigger models get exponentially better at that stuff. So I feel like this is the biggest one about an LLM, right? It's trying to continue text, right? So if you have sort of the implicit thing that you're thinking as you write it, it's actually really hard to make that not show up in the query, right? So if I say like, here's my idea, do you think it's good? I want it to think it's good, right? It's my idea. And it's actually kind of hard. Yeah, it's like, oh yeah, it's great. If you ask it, here's an idea, I want you to evaluate it. That's a very neutral phrasing, right? Like I'm not saying that I think it's awesome or terrible. I think like I want to know what you got about it. And then it's actually willing to say like, oh yeah, people do the same thing. I noticed when I show up, I had some alums come back and like, it's like they want to see the robot. And I'm like, yeah, cool, here's the robot. I'm like, that's really neat. And I'm like, cool. Do you think there's anything that could be improved, right? Like, and as I'm saying, and they're like, oh, okay. Yeah, this joint is never going to work. It's yeah. So you really want to, you have to tell it to give you feedback if you want feedback because it'll figure out what most, and it's not even necessarily what you want, it's what most people want, right? What their training data has gone with. Okay, so I've absolutely had this happen. So like a vision language action model, right? I ask it, hey, what animals are in the photo of a picture that has no animals? And it'll say, oh, I see a pig hiding behind something or other. You ask it, okay, you ask it then what's in the photo, and it says like, oh, I see some bricks and tools and sand and the pig, of course. And if you just ask it what's in the photo, it says doesn't see the pig because there's no pig, right? It just made that up because you said you asked it what animals are in there, and that's like that hurts me, right? So context pollution. Once it knows a thing is there, that those tokens are up there. And future answers are going to be kind of conditioned on those tokens. So honestly, like, yeah, Kemp, so don't trust it at all, right? And in particular, yeah. So they don't understand reality. That's not something they're trained on. They understand the textual description of stuff, right? So, and it's not even like lying to you, right? Like if so let's see if it's come up with some oh, all right. So here's my papers, right? The papers match completely with the lies it already told you because those are in the context window now, right? And it's going to say, yeah, in 2011 wireless sensor network. So it's got a DOI, right? You can click that. Doesn't exist. No such thing as you might expect because that none of these papers exist. None of these are even close to my actual papers. Like this is just completely like, man, it's got 180 citations. It actually ordered them. Okay. This doesn't really, so a bigger model would cover its lies tracked better. They're making the citation count. Yeah. So hallucination is just finding the next token randomly and coming with something that doesn't match what human thinks is reality. And it's you got to be really aware of the just the fundamental way that this stuff works, right? It talks absolutely. It has no idea what it's saying, right? It has to reread it every time it makes a new token. So if it makes something up, it's going to try and you'll actually literally see it kind of like it get screwed up and go down a path, and it's like wait, and just stop mid sentence, and then say like okay, I gotta do this correctly. So the description I heard like this like prodigal teen who's sometimes on hard drugs. You can't really tell over email whether, is this the cocaine talking or is this like the genius buddy I've got. Yeah, so it knows like, and this really impressed me. This was Mistral from about 3 years ago. One of the biggest models. I was amazed. It was like, it knows about moose and ptarmigan and kind of some stuff about them enough to be able to like do the sort of basic, like which one's bigger. Like moose is the largest, so moose is bigger. How many R's are in reliable? The tokenizer actually does make this like a token, a token, a token. So like it doesn't really, letters are not even a thing it kind of has base access to. So it'll say, oh yeah, there's 2 R's. Yes, it's spell Cincinnati and put a G in there. And like, where is it? Oh yeah, it's after the H. And it's like, what? None of those things make sense. So to minimize, so the question is, how do we minimize the impact of having these hallucinations on our results? And I mean, query hygiene, right? Of like, don't give yourself the opportunity to accidentally put your framing of the problem in there, because then it'll just confirm it, right? So shorter is better. I mean, Hemingway, I feel like is better. If you want a scientific answer, if you want precision, you need to use scientific language in your query, right? Like how credible is this explanation of the data, right? Using data, credibility, these are good phrasings. Whereas like, do you think it works? It's implicitly figuring out that like, oh, you're a moron. I need to give an answer that a moron would like, and that's not necessarily going to be the right answer, right? So yeah, and honestly, this is so. I always think of scientific terminology. It's like these tongs that we use to keep from like contaminating the sample with our own thinking, right? That we're just like handling in the third person these different concepts. So it gives you sort of linguistic distance from the thing, right? Is a good idea. So I'm sorry to say my animation's okay. So can't quite tell when the animation is going to finish. If you have a really important question, I've had reasonably good luck not just asking the question. Actually, one of the worst phrasings for a question is yes or no, complicated question, because you've given it literally one token to tell you yes or no. It has to figure it out in that one moment. So if you ask for the principles, and then you say like, okay, here's the data, and I don't want your conclusions about it, right? So you don't give it the data first, that'll use it, right? So you say like, how would you analyze this situation? You have it like fill up its token space with a bunch of good principles of analysis. You give it the data, and then you have it like, and you are the quality control here, right? So if its principles are like good crap, you got to regen it, right? And then maybe make notes or something so you can supply the good ones if you if it hallucinates something or other. I've never had good luck getting that out of the context window, right? Especially bad with code. So basically, like if you argue about it, that just has the bad thing, and then more tokens that are trying to make it contradict the bad thing, and like there's no, I have a hard time coming back from that kind of stuff. Yeah, so I just have this. So /clear seems to be an increasing standard on that stuff. Again, if it's an important question, several unrelated models can give you a better picture than just try one model and like it told me this, so that must be the truth. Yeah, and yeah, you are supplying the reasoning that doesn't have. It's supplying the sort of context and knowledge that you don't have. So, Roy. So good and bad. So the good. You want a complicated concept explained in basic terms, and you can interactively go back and forth. You can't go terribly deep before it runs off the end and doesn't have a good alert model for that. If you have a hard time writing the sentence good, this can make your text sound less weird pretty effectively. So if people have a hard time understanding what you're saying, or it's just like, you could phrase it that way. This is definitely a useful tool, and I mean, starter code is honestly totally incredible. I've been trying to like port a bunch of stuff to Swift. I don't know much Swift at all, and I don't have to read the documentation. It can just spit out something or other. There are drawbacks on each of these things, so it'll explain a basic concept, a complicated concept in basic terms, and they do not understand what they're saying. So if you try and go deep, it will just happily like give you something that kind of glibly appears. It's like the old sociopath deal where it's like glib liars that will just, continue the text that yeah. So if you've got a pet physics theory, if you're like predicting something new about computing, like something that is non-verifiable, this is super duper bad. And it's literally AI-induced psychosis, literally a thing. This is, it's actually kind of interesting to me. Gemini 3 didn't like these slides, so there's and this is about 6-year-old work here. It's the extrapolation problem is where you get some training data set in green, and it's modeling something complicated. LLM tends to do terribly outside the training data set, and in fact, it doesn't. Like your expectation would be that if it knows if it interpolates so well, you'd expect it to be able to extrapolate relatively well. It tends to just go haywire. Like no one would look at, the 5 cycles you have and say, oh, it probably just trails off outside the domain. Like that's not what you would predict. So Gemini 3 says like it thinks it can extrapolate. You can follow the rules, figure those out. Yeah, for text, the text is just mid. I mean, I see this a lot. It's when it's been trained, a base model is shooting for the average way to describe this, and then, temperature spices it up a little bit. Reinforcement by learning human feedback has just added gloss with adjectives, and the ideas are still like not even like absent or confused or something. M dash is an emoji. This is honestly like great. So here's this amazing sentence that has a lot of adjectives and says nothing, right? There's no deep idea there, and there's a lot of M dashes and emojis, right? That's how it's trying to like, it's just junk food, right? I'm used to good writing conveying some interesting concept into my head. There's no concept, right? Yeah. So right. See, starter code is really great. In a large code base, they make errors they can't fix, and that's because they don't seem to have good judgment. Actually, they do not seem terrified of like starting to do a thing and building a duplicate of a thing that already exists over there, but worse, right? And that's super bad for scaling the code. So you get these like they're also shooting for the average code, implementation. And the average implementation has a couple of security bugs, it's got a buffer overflow, it doesn't handle this corner case, like that's not what you want. Yeah. So the people are like, oh yeah, last night I vibe coded a 100,000 line web service. And I'm like, you poor bastard. Somebody has to maintain that 100,000 lines if you want to keep using it. That's not, yeah, it's not great. So I asked Gemini 3 Think to fact check these slides. So I had this little icon. So I'd like you to review these slides. I'm particularly interested in slides that contain misleading information. They aren't necessarily complete. It figured out they were my slides, I think because I was logged into Gemini 3 with my Google account, and like the owner of the slides and the title page says that it's so oh, your slides are, which, okay, fine. I thought it was quite good, honestly. It also came up with, let's see, the follow-up. So I said, like, are there things that Gemini 3 should add? And okay, so yeah, it listed me a couple, and here's what faculty, data privacy. This is actually really nice. Neat. HIPAA is not relevant to us, but like FERPA, it really is. I'm realizing I could do like a homework assistant that used a local large language model and wouldn't be FERPA implications. It could say like I could make it clippy. It pops up and says like, "Hey, looks like you're having a hard time with this homework." Research reproducibility is really good. Mention that, yeah, and pedagogical sandbox. Honestly, I think we should probably be giving more AI required assignments rather than AI forbidden assignments. So say like, hey, use AI to explore something that you know already. Tell me what the factual and conceptual errors are here, right? And because it looks really great from a casual inspection. Yeah, so for students, consumer architect, you can understand retrieval augmented generation, quantization, local, yeah. So people want to know that stuff. I actually kind of think when when we exit the era when like as many hundreds of billions of dollars of capex and opex that the AI companies want is just going to flow in there. If assuming we reach a steady state, that's going to go away. And it's going to be like, you can run a local model and get dedicated access. And what they're saying is like, we don't have to pay for the servers to run your crap. Maybe it'll fire back out to our stuff. So, and there's stuff like if you want to understand the safety and security boundaries, you might role play as someone who's undergoing schizophrenic, episode. A cloud hosting service can literally call the cops on you. And I mean, I definitely wouldn't recommend actually having a schizophrenic episode on a local model because then no one will know that you're getting in trouble. Yeah, but yeah, so and you can see what it really thinks about something or other without it being recorded necessarily forever. Yeah, and yeah, save subscription fee. It seems plausible. And yeah, again, this is what ChatGPT. I should have had ChatGPT like make its presentation of the stuff. The university digital sovereignty. I don't really know what that means. Yeah. So it is honestly kind of seems goofy to me that a student that can pay for the like super advanced subscriptions has access to a better AI right now than the student who can't. So there's a equity issue there. Yeah. And these things can be very, very efficient, right? That like the stuff will run on my laptop, use a couple hundred watts of stuff. Yeah. So, one thing that I did not show off. We are currently running a version of it's llama.cpp hosted, and it's sitting at on the UAF supercomputer, and this is not it. So I get this linked somewhere in here. So at llama.cpp. So you can compile and set up llama.cpp yourself. This is the notes for how to do that. This is a link to a 27 billion parameter model, which, like I say, is about 10 times bigger than I can fit on the one on my laptop. Seems to be pretty good. And it's got the llama.cpp web interface, which does let you, so a couple of neat things about this. It does have like, so it's got a history. So this is local on you. This is the history looks like, ChatGPT stores this history stuff. This is stored on my own machine. It's not on the server there. This model actually lets you attach images. So I could do, let's see, one that I've done before. That would be good. In the home directory, thought I had this. Okay, so this is a fox in Fox, Alaska. So what's something you can ask about this?
What is it?
Yeah, what do you see? So it's called a multimodal model, and thinking about it. So it uploads the image, and it's a fox. It's cool. Understands that it's a grass and vegetation. Yeah, plausible. It is in fact taken with a trail camera on my driveway. Snapshot of Washington actual habitat. What's okay? Super easy to get in trouble with this stuff. So I took this photo with my trail camera, cropped it out. There it is. It's a real photo. Does it appear manipulated? Let me tell you, every image in history, you could say like, look at these pixels, they're doing something weird over here. I don't know. The closer I look at it, yeah. So, yeah. So I should. There's something off, but yeah, I mean that's true. Real animals and real. It's a real photo, but it'll get. So you notice this is a really leading question, right? Like, hey, does this seem manipulated to you? Or like, I agree. And it's really so implicitly during the training process, really encouraged to give you the answer you seem to be fishing for, right? Which is very hazardous thing. Cool. If you have questions, observations.
So is this link available on the document Orion web?
Yes, yeah. So so the tinyurl.com UAF 2026 AI. And that's this document. It is editable for today. So actually, if you have if there's other tools or models or ideas, please yeah, drop them in here. I should have I probably should have.
Is the link on the document where you are learning the?
Yeah, so at the bottom of that document is this Gemma 3 hosted link. I mean, this is I don't really know what happens if several people are using this at the same time. So
Okay.
yeah. Cool.
All
All
right.
right.
I think we need to stop here now. And wonderful presentation, Orion. So have a wonderful applause for Orion. And that was really great. And all the materials, once again, are available in our Data AI Lab website. So if you could just, if you are not done yet, I mean, just go to this, scan this QR code and access the material in our Data AI Lab website. All right. So all the materials will be available there. So, well, thanks for attending. If you have any question, let's take it online outside the class. And Zoom participants, please feel free to send us email and all these things. We will meet in another 2 weeks with the topic Linux Foundation when Kevin Galloway from RCS will present the basics of Linux and high performance computer. Thank you.
Lawlor. I sent you an email not too long ago.
Yeah.
You remember.
Yeah.
I have to relay my comment to you.
Okay.